Welcome to my talk, Smart Goals if the environment joins in. Measurability delivers objectivity. However, ignoring some simple statistical principles, one can do a lot of damage. With this talk, I would like to sensitize that a sensible interpretation of measured goal attainments is markedly more complex than often suggested. Looking at the experience, the danger of abuse seems to be pretty high. Management by objectives. Who doesn't know this term? Peter Drucker has introduced this term to management theory in 1954. Mantras like, goals are supposed to be smart. A goal is smart if it is clearly defined, specific, its attainment can be objectively stated, measurable, its attainment truly signifies the attainment of the goal, adequate, and it's realistically attainable in a specified time. Now, let us assume that the environment does influence the achievement of the objectives. What does that mean, or what is the impact? Popular management literature spills over with many books published on SMART goals. Astonishingly, however, little is written on the effects of the environment and the role it plays in developing SMART goals. It remains silent on this topic. Astonishing because any significant influence of the environment has a direct significant impact on any measured goal attainment. So what can we expect? How large will the influence of the environment usually be? Let's have a look at two extreme cases. First, let us assume that the goal attainment depends exclusively on my own effort. With this assumption, the end of result is unequivocally attributed solely to my efforts. Why is that uninteresting? Because I usually do not work solely by myself. Interactions with my fellow humans are excluded completely. Our dealing with uncertainty, one of our greatest strengths, is left out. Secondly, I cannot influence the goal attainment at all, so independently of what I do, it comes as it comes. Surely this is not a good goal. Now what follows? Usually our own influence on the goal attainment will be of the same order of magnitude as that of the environment. This introduces a statistic jitter on the measured values that is of the same order as the measurement range. As a result, the single measured value loses its significance and questions with respect to the statistical distribution of the measured values come to the fore. A simple conclusion from the measured goal attainment to the own performance is not possible anymore. I would like to illustrate the relevance with a short example. The smart manager has overtaken a department for the solution of customer messages. There are 200 employees. Everyone solves 100 customer messages a year, and the employees are rated for each solution by the customer with a mark between 1, excellent, to 10, unacceptable. He needs to improve the quality of the message processing. Young and fresh as he is, he wants to enforce this target with an incentive system. Hence, he asks for the distribution of all evaluations of his employees and states that all marks occur. However, good marks range from 1 to 3 occur much more often than bad marks. And the average? Roughly 3. And how are the averages of my employees distributed? He asks further. Voila! And he notes that his employees' performance seems to be Gaussian distributed with an average slightly less than 3 and a standard deviation of approximately 0.2. Hence, an incentive system is tinkered quickly. As an objective, he determines a 10% improvement of the average to 2.7. He breaks it down to the individual as following. Here is the bonus axis, 100%, 50%, 150 and 200%. As said, with 2.7 as 100% achievement. Now who is better shall get more, 10% for each 0.1 improvement, with a cap at 200. Who is worse shall get less bonus, let's say 5% less for each 0.1 deterioration. Those who are worse than approximately 2 standard deviations, that is worse than 3.2, so truly bad, get nothing. Now, is proceeding like this smart or dumb? Dear audience, what do you think? Prudent or imprudent? If imprudent, what problem did our young and eager manager overlook completely? Actually, all diagrams result from a model calculation which is based on the assumption of 200 identical employee clones whose distribution of evaluations is this one. If an employee handled infinitely many customer messages, then his evaluations would indeed be distributed like this. It actually matches real evaluation distributions quite closely. But an employee does not handle infinitely many, but according to the model, only approximately 100 messages per year. Her evaluations therefore only represent a finite sample. The average of the sample will deviate from the average of the distribution. The 200 employees differ therefore only because their 100 measurements are randomly distributed according to this distribution. No individual specific factors were involved in the selection. Hence, qua model, all employees are identical. Their on average different evaluations just result from the diverse influence of the environment, like level of difficulty, qualifications of the customer, help by colleagues, position of the moon, you name it. Here you see the sample of one employee compared to the basic population. In the upper diagram, you see the basic population of all evaluations, and in the lower part, the sample representing a single employee. And now we are looking at all 200 employees. In the upper diagram, you see now the frequency of the evaluations of the first employee. The distribution of the population is blue. The red line is the average of the employee. The lower diagram shows the frequency of all employees' averages. Currently, there is just the one tiny entry for the first employee. Here comes the second employee. One can see that the average deviates from the first because of the different sample. And now the other 198 employees. One sees quite nicely how the distribution of the averages converges to a Gauss-like distribution with an average slightly below 3. Now, is this pure coincidence? No. The central limit theorems of probability theory states that the distribution of the averages converges against a Gaussian distribution with increasing size of the sample independently of the form of the original distribution. The shown distribution of the employees' averages therefore is Gaussian just because of statistical reasons. Now what happens if not all employees process 100 messages, but some do 50, perhaps more difficult, others 200, perhaps less difficult messages, etc., like it is more realistic? Correct. Then the distribution of the averages becomes broader, still without any significance for any performance difference. Are 100 measuring points the rule? Rather not. Often there are just single measurements and no averaging at all. What could we say about the performance of someone where the only known fact is that he was evaluated with a, let's say, bad 8? Virtually nothing. How large is the variance with single measurements? Correct. For single measurements, the variance is that of the original population. If one doesn't have the practical experience, it would be almost unbelievable that companies do link really large sums to such single measurements, be it margin or profit or something else. What a dangerous nonsense. The bonus system of our management colleague would have evaluated the majority of his employees wrongly negative and provided them with less bonus than the target value in a completely arbitrary manner. Wrong negative treatment is perceived as unjust punishment. Put yourself in these employees' shoes. How long do you remember this? Now, does the incentive system fail to have any effect? The desired effects, namely rewarding the good and punishing the bad, surely. But the undesired effects, they will probably occur. Competition instead of cooperation between the employees, processing of simple, less complex messages, etc. Let us finally summarize the central points. Objectivity does not imply simple interpretability. The benefit of objectivity that comes with measuring goal attainment also enforces us to understand at least some of the basic mechanics of statistics. Otherwise, we risk, in the best case, to waste a lot of time in hunting down the phantom of statistic artifacts. Any influence of the environment onto our goal attainment results in an additional scattering of the measured values. Usually, this influence is significant. Then, without knowing the variance caused by the environment, goal attainments, especially single goal attainments, can hardly be interpreted. Single-valued targets, referencing even averages which may seem reasonable at first sight, may be completely misleading. The very finiteness of larger samples already leads to Gaussian distributions of averages, faking differences where possibly no difference exists. So, no significant difference, no action. If we do want to use measurable objectives to determine whether two employees differ in their performance or whether a single employee performed differently with respect to a given population, well, then we have to know whether the values are ordinal or interval scaled, and then we have to use suitable statistical tests like Kolmogorov-smirnov. And if this doesn't sound familiar to you, you better be very cautious with such comparisons. And last but not least, please consider that the discussed influence of the environment is just one small area of what makes behavior control via objectives distinctly more complex than some might have expected. Other areas are, for example, the curse of dimensionality or the semantic shift by money binding, but this is a matter for further contributions. Thank you very much.